Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see derivation on torsion of an arbitrary section beam. Earlier also we had seen the derivation, right? And already I told you related to that other derivations are also there. So based on this, how we will find or how we can solve the numericals, right? That also we will see, and the same at the same time, the derivation of second type, what they can ask or how they can twist the question, we will see in this derivation. So that's why I just put here this one, right? So derivation on torsion of an arbitrary section. This is, you can say that part 3. Okay, that we will see here. So now the question is, derive the equation of tau r for a given geometry. So now here what we have to derive, tau r means we have to find, just instead of derivation they can ask to find the tau r for the given figure, right? So now this figure is there. So see, similar we had seen earlier also, in that what was there, like this type of sweep was there, right? From here 1, 2, 3, 4, this was there, right? So this we converted into the similar this type. So now instead of giving this type of question, they given the next step of this figure. What we drew that in that video, in that question, we just modified and then converted in the same figure. So now instead of that, what they given, they instead of this, just to confuse, directly they given this one. Now no need to project this figure according to this question. So directly we can go with this one. So like that also in exam, they can just modify, or they can just in between of the any step they can ask, because in there we had seen that many derivations are there, many points we need to find. So with that we can find. Okay, so let's start with this one. So let's see here. Okay, so this is of what axis 2a r naught versus the s, that is the that axis is there, in which from here to here it's 1 to 2, 2 to 3, 3 to 4. So now this we can just like, this is 1, 2, 3, 4. These things are there. So now this we are projecting in like this. So here 1 dash, 2 dash, right? So up to 2 it will be only 2 dash. Then from 2 to 3, okay, so 2 to 3 it is 2 dash, 3 dash. So just see here 2 to 3, and then 3 dash to 4 dash, that is in between 3 to 4. So now just see here. So you can see one triangle, and then from here, that is 2 dash, 3 dash, and 2, 3 is what? Rectangle, and another triangle. So here this is triangle. So once we will find this triangle, that will be same for this triangle, and then we have to use that for this rectangular part. That's all, right? And so here this distance also is given as what? This as hd by 2. So this we have to take care. So now let's see what was there. We had seen that 2ar equals to 2a r naught minus 2a dash r. This was the right. So for finding 2ar, what we are doing, 2ar naught from 2ar naught, that is from this figure. Okay, that we will see, and subtracting 2ar dash. So that is given here. So that is here 2ar. Okay, so this value is your 2ar. This is total what? 2. So here, now just see in the image. So here this is 2ar naught, and this is 2ar dash. So what happened? Subtraction of this from here, right, will be the 2ar. Okay, that we have to use. And in that also, it's a given from 1 to 2d, 2 to 3h, and 3 to 4d distance, that measurement is given. Now we have to use this one to derive the torsional formula. Okay, so let's start. Okay, the beam is loaded by a pure torque so that the axis of twist passes through the shear center. Right, so just see again, pure twist is there, means that must be passes through the shear center, only then the pure shear, that means pure torque will be there. Otherwise what happened, the torsion also will be there if any other places if force will get applied. So here at shear center SR only, that torque should be there. We shall take the origin for S at the point 1 and initially plot 2a r naught against S to determine tau r. So what we will do, first we will plot 2a r naught against s. So 2a r naught versus s. We plotted this one. So now this plot directly they given here. The position of center of gravity, that is 2a r dash of the wire 1 dash 2 dash 3 dash. So 1 dash 2 dash 3 dash and 4 dash. Okay, is found by taking moment about the s axis. So now taking moment about this axis. So like this it will be rotate. So taking moment about the x axis. Okay, so see the equation of moment, what will be the moment about x axis. So what we have to do, we have to take for this part, then this part. So 1 2 3, or you can say 1 and 3 is equal, right? So that we can take. So now just see here. So the moment will be t into 2d plus s. So just see here, this is how much, d and d, 2d plus s. So this total distance is 2d plus h. Okay, so t into 2d plus h into 2ar dash, right? That should be equals to td into h by 4. Okay, plus td in th into hd by 2 plus td into hd by 4. So this is for the triangle, this is for the rectangle, and this is for another triangle. Td into, or you can say half into td into hd by 2. So half base into height for the triangle. And similarly here d was there. For this rectangle h is there. So t h into hd by 2 base into height or breadth into height. So this is for rectangle, and that t in the multiplication of this is the distance. T into hd by 2 is what? Area, and h is the distance to multiply. Okay, so now finally what is there? So after simplifying, means how we will simplify? Just expand this one. So first here 2a are that is keep fine. Just simplify here. So this will be t multiplying here, t h d square by 4, this term t h square d by 4, plus from here t h square d by 2 plus again here. So t d square h by 4. So if we will add these two, what we will get? T d square h by 2 plus t h square d by 2. Now what we can take common, right? So hd we can take common from here, thd. So t h d taking common. So what is left here? thd. So this will be d, this is h. Okay, so t into hd plus h. So this will be there by 2. Okay, so now for this one, now so for this what we can write, this as t into 2d plus h into 2ar dash is equals to here this value, t d h into d plus h. So now if you will find 2a dash r, 2a dash r is equals to what? So these things will come this side. So t d h into h plus d, or d plus h, both are same, right? Into t into 2d plus h. This t cancel, and by 2 here, this 2. Okay, so now what we have? So from here 2a dash r is equals to dh into h plus d by 2d plus h. Okay, into this 2. So see hd or dh into h plus d by 2 into h plus 2d. So now we got 2ar dash value. Earlier in the previous video we got the different 2ar dash because that time shape was different. So that area depends on what? That 2ar dash value. Right. Now tau r follows the moment of inertia of the wire about the axis, okay, through its center of gravity. Hence tau r. Now in terms of moment of inertia, what is the formula? Will be dq by 12. So just r depending upon what is there. So here in terms of what? Moment of inertia of the wire, right? So just after finding this one, 2td into 1 by 3. So this is 2 for 2 triangle is there, that's why. Okay, PD into 1 by 3, where it will act at 1 by third of this one, because its triangle is there. So where that center of gravity will be there at 1/3. So that's why it is here at 1/3 into HD by 2 whole square. Okay. Next, TD, this is for rectangular. So TH into HD by 2 whole square. This one minus this square. The square of, so whatever, because 2AR dash. So total minus this one only we will get the final one. So this HD into H plus D by 2 into H plus D whole square into T into H plus 2D, whatever the distance is, this one with along with 2AR. Right. So this will be the what? Tau R value. Now this we have to simplify. Okay. So let's see how to simplify this one. Okay. So this will be what? After this multiplying h square d square by 4. So this will be 2t. I'm multiplying here directly. Just let me write 2d into, or 2d by 3 into h square d square by 4. So this term becomes what? 2t h square dq by 12. Right. So I'm writing here just 2t h square dq by 12 for this term. Okay. Now similarly for this term, this will be th into h square. So th into h square d square by 4, or you can say this one as t hq d square by 4. So of that one, just here, just we got here 12. So we are just making in terms of 12, then it will be easier. So what we are doing, multiplying and dividing by 3. So this will be 3t hq d square by 12. So for this term, we can write that as 3t hq d square by 12. Now this term we have to simplify. Okay, and then further we have to simplify this also. So now this will be what? Whole square of this one. So first let me multiply this inside and then their whole square. So this will be what? H square. First I am multiplying these two terms. So this will be first this h square d plus h d square. Okay, whole square divided by similarly 2h plus 4 d whole square. I am just first simplifying this one, then we will multiply this. So after this, just expand with the a square plus b square formula. So just see after expanding what we will get. Okay. So after expanding this, we will get what? H square d whole square plus h d square whole square plus 2 h square d into h d square by, or just first simplify this one. Okay, so this will be what? H square h power 4 d square. I'm just simplifying the numerator, then we will see this one, h square d square plus, after this will be h square d power 4 plus this will give you what? 2hq dq. So this is our numerator term. Now we are simplifying the denominator part. So denominator part is 2h by 2h plus 4d. So 2h square, right? 2h whole square plus 4d whole square plus 2 into 2h into 4d. Okay. So after simplifying this, so what we will get? Right. So after this is h power 4 d square plus h square d power 4 plus 2h cube dq by. So after this we will get 4h square plus 16d square plus 4 into 4, 16hd. So 16hd. So this part we simplified. Now with this term, you have to multiply again with this term. And then you have to take the LCM and all and simplify. So after simplifying this one, what we will get? So after this one, you have to just multiply this and then add and subtract depending on the sign. Finally, after simplifying, what we will get? Tau r equals to 2 dq h square by 12 into 2h plus d by h plus 2d. So just see here what we are getting common. From here, if you will see this, we are getting h plus 2d, but here 2h plus d. So nothing is common here. Okay, so this is the tau r value of this one. So t into dq h square by 12 into 2h plus d by h plus 2d. Okay, so now from total torque equation, okay, so we got here this torque value. Now, if suppose in that same, if they will ask to find the angle of twist, right? So from the same figure, we can find here a derivation of an arbitrary section beam to find what? To find angle of twist. I missed here to write. So we can continue that as to find the angle of twist. Okay, so let's see from the total torque equation that what we have. The total torque equation, just see here, this first according to this question over. But now I am continuing to find the rate of change of that twist. Okay, so if suppose they'll ask in that one, then how we can continue? If suppose they ask to find the tau r, just after finding this, stop the question. That answer is over. But if suppose they'll ask to find the rate of twist, then this also is required. So that's why I am continuing along with this same. So we know what tau equals to gj into d theta by dz minus e into tau r into dq theta by dz q. Okay, so this is the torque equation that Venant and this one, this already we derived, right? These two, so Venant and Jarma, this equation. Now we solve for d theta by dz. So for this we will solve. So how to solve? So just see here what. First, they have taken just gj by e tau r, gj by e tau r as mu square. Okay, so just see here on this one. So now after this, what we will get? Or because d theta by dz we have to find, right? So just multiply because for solving the linear differential equation, what should be there? The higher power should be free from the anything. That means their coefficient should be 1. So but here coefficient is this one. So let me write first simplified way. So I'm taking this all to this side. Okay, I'm keeping this. Okay, so just here. Or just take with minus sign. So this will be minus t equals to minus gj into d theta by dz. This becomes plus because this is required to plus e tau r into dq theta by dz q. Now what we have to do? We have to make this as coefficient 1. So we just divide with this one. So minus t by e tau r, okay, is equals to minus gj by e tau r plus dq theta by dz q. Now just I am writing this one in arranged way. So dq theta by dzq, okay, minus gj, sorry, here d theta by dz is there, gj into gj by ei into d theta by dz is equals to what? Minus t by e tau r. So this is our differential equation that we have to solve. Now what we are assuming, so gj by e tau r, right? E tau r. For this we are just considering this as mu square, just taking the, so that becomes the smaller one. Okay, so now what we will do? We will just replace for what? gj by e tau r as mu square, right? So just see here, this is not there, right? So for this we can write simply mu square. But what about this one? Here t by er is there, but gj is not there, but we require gj by er, right? So what we have to do here, just we have to multiply, divide by gj, right? So after that what we will get? After substituting, right? So dq theta by dz square, and for this is mu square, so minus mu square into d theta by dz, that is equals to minus. So now just see here, gj by e tau r is mu square, but what we have, e tau r only. What is required? Into gj by gj. So this gj by e tau r will give you mu square, and this gj will left. So minus mu square into t by gj. So now this is our final differential equation after simplifying or after taking mu square as gj by I, so that it becomes simpler. So now this differential equation we have to solve. So it's a power of 3, right? So now after the solution of equation 3 is of a standard form, that is whatever the higher power is there. So this is the solution of this, right? So here this constant is there, so that term will be added. Either you can add here or this side also, that is not the issue. So d theta by dz is equals to t by gj plus a cos mu h plus b sin mu z plus b sin h mu z. So here, because in terms of z we are finding. Now after this, what is there? So where a and b are the constant of that differential equation. So for that solution, so means what? Now we have to find the value of a and b. How we will find? Earlier also we had seen such type of question. Means we have to apply the boundary condition. After applying the boundary condition, means 2 unknown is there, so means we have to apply 2 times boundary condition. So once we will apply the boundary condition, we will find the value of a and b, and then we will substitute back here. Then we will get the final d theta by dz value, and this d theta by dz is the only what rate of twist. Okay, so let's see next. Okay, the constant a and b are found from the boundary condition. That is here. At the built-in the wrapping, that is w equals to 0, since w equals to what? Minus 2ar d theta by dz, then d theta by dz 0. So simply you can say w equals to 0, then dz by d theta by dz is 0 at the built-in condition. So let's see here, this d theta by 0 at the built-in condition will be there when z is equals to 0. So just here, at the free end, sigma equals to 0, as there are no constraint, no externally applied direct load, because it's a given, only the pure torque is there, no other things is there. Therefore from equation, this I just mentioned for the reference why this is there, right? Because for other derivation is there, so we cannot keep anything. So you can just refer the Maxian book of 27.1 equation number. There you can see that. Okay, so d2 theta by dz square as 0 at the free end. So at the free end means what? Z is equals to 0. So after putting z equals to 0 here and d theta by dz equals to 0. So just see what we will get. Okay, so now putting d theta by dz equals to 0. So 0 equals to t by gj plus a cos h into mu into 0 plus b sin h mu into 0. So this term will be 0. Cos this will be 1. So t by gj, that is 0 equals to plus a cos 0 is what? 1. So 1. So from here a equals to minus t by gj. So now we got a equals to minus t by gj. So just see here, a equals to minus t by gj we got. Okay. Now next what is that? We have to find b. Right. So let's find b. So again another boundary condition we have to apply. So just here, from 2, b equals to t by gj into tan hl. Okay. How? So again that is just see the condition. Sorry. Second boundary condition was here. At the free end, sigma 0, no constraint, no externally applied load, means d theta by 0 square is 0. So once we have taken z equals to 0, now the another boundary condition will be what? And z equals to L. So just apply that one. Okay. So just see after applying, okay, you will get the value of b is equals to t by gj into tan h mu L. Okay, so B by Gj equals to T by Gj tan H mu L. Now substitute this in the previous way. So we will get d theta by dz equals to what? I'll just see here what is the equation. D theta by dz equals to what? D theta by dz equals to T by Gj plus A. A what we got? Minus, right? Just see here what we got, A minus T by Gj. So minus T by Gj into cos mu, right? What will be the z? That z will be what? For all, that will be L only, right? So cos mu z, okay? So cos mu z plus, now what we got, B, just see here the B value, T by Gj into tan mu HL, okay? So plus T by Gj into tan mu HL, okay? So this is our final equation. So now just see what we can do here. T by Gj in all the term, that we can take common. So T by Gj common. So this is here 1 minus cos mu z plus, okay, tan mu h l. Okay. So this we will get here. Okay. Tan mu h l. I'm sorry. Sin mu z also will be there because this into sin theta is the B. So this is the value of B into sin mu z, right? So tan mu h l into sin mu z. So this will be d theta by dz value. Okay. So now we have d theta by z in terms of this one, right? So now just see here. So d theta by dz equals to T by Gj 1 minus cos h mu z plus tan mu l into sin mu z. Okay. Now further we can simplify to this one. So just see how we can simplify. Okay. So up to this, if you are writing, then also it's a fine. This is the simpler way of this one. So this answer is also what? Up to this, if you are writing and if you are keeping, then it's fine. But if you will write up to this, that is the more appropriate. So let's see how we will simplify to this one. Okay, from this to this one. So what we have, d theta by dz equals to T by Gj into 1 minus cos mu h, right? Plus, I'm writing for this tan mu l as sin mu l by cos mu l into sin mu z. Okay. Now, just this part I'm simplifying. Okay. So, T by Gj, okay, 1 minus. So, now after taking LCM, what will happen? This will be cos mu l LCM. And from here, this will be cos mu h into cos mu l, okay, minus sin mu l into sin mu z, right? This will be there. So now, just see here the formula cos A, where A is, just we are taking this one, that L, okay? So A and B. So cos A, cos B minus sin A, sin B. So that is the formula of what? Cos of A minus B. So this we can write T by Gj into 1 minus, this is what? Cos of A minus B. So mu L minus mu Z by cos mu L. So everywhere this H is there. Right. So in another term, you can write T by Gj, that is d theta by dz, is equals to T by Gj into 1 minus cos of H mu L minus Z by cos H mu L. So see here, d theta by dz equals to T by Gj minus into 1 minus cos mu into L minus Z by cos mu L, right? So cos H mu L. So this is the rate of twist, that d theta. So if the same figure, they will ask you to find the rate of twist. From there, you can find this one. If suppose they ask to find the torsion only, then what you can do? You can simply find up to this one. If including rate of twist and torsion, then you can just simplify up to this. This is the solution, and then you will have this final one up to this one. So this is the rate of twist formula. Okay, the first term in equation 4, okay, is seen to be the rate of twist derived from the Saint-Venant torsion theory. So the CR, if you multiply this one, what happened? This will be T by Gj, that is the Saint-Venant, thus also here was there, Gj into d theta by Tz, right? So from this one, okay, from Saint-Venant torsion theory. Now, the hyperbolic second term is therefore, so the CR, power, right? So this cos h is there, means hyperbolic it is, and that hyperbolic function. The hyperbolic second term is therefore the modification introduced by the axial constraint, right? Equation 4 may be integrated to find the distribution, right? So now this is for integrate, right, to find the value of theta. Okay, so to find the angle, that is rate of twist, this is the twist angle, right? To find the distribution of angle of twist, right, theta, the appropriate boundary condition being theta equals to 0 at the built-in int, that is, so after the theta will vary from 0, that is at the free end. Okay, so now let's see, theta equals to, after integrating this one, so this will give you what? So this is constant out of the integration, so this integration will give you with respect to z, so z minus, then this you have to integrate. So let's see, after integrating we got this value. Okay, so sine of integration, then cos. Okay, so that is equation 5. And the angle of twist theta Fe at, so this is the angle of twist at the free end. What happened? End of the beam is, right, T by Gj, that here what will be there? That z becomes L. L. So now this will be sine mu HL by mu, that cos mu HL. Okay, and this term will be what? 0. So that becomes cos, that is tan mu HL, and this mu is there, and here we are taking L common because with this term L is not there. So at free end what happened? This value will be 0. So what we will have? Theta equals to T by Gj, okay, into, for z equals to L. So after, because here z is L, if you will put L minus L, or just let me substitute from here. So z is L plus sine mu L minus, replacing that to L by, sorry, here this is L, by mu cos mu L, this term over, minus sine, here that is not required, so here because z is not there, so this will be sine by cos, so that is tan mu L by mu, right? So L minus L 0, sine 0, 0, so this term will be 0. So now after this what you will get? I'm just here. So theta equals to T by Gj, okay, into L plus here, sorry, L plus, so here this is minus, so L minus what? Tan mu L by mu, right? This will be there. Now take L common, so with this term L is not there, so what we will have? Theta equals to T by Gj, okay, L also common, means here what is left? 1 minus tan mu L by mu L. So let's see here, theta at free end, Fe that stands for, that here at free end is what? TL by Gj, TL by Gj 1 minus tan H mu L by mu L. So this is the rate of, this is the angle of twist, this is angle of twist at free end, and this was what? This is the angle, that rate of twist. So let's see here, with this we can find 3 things. First, in this we found 4. What? First, here, tau r. What is the value of tau r? Now after finding the tau r, what we can find? The rate of twist, right? So for rate of twist, we simplified this equation, right, from the Saint-Venant and this one to the total torque equation. After that we found the d theta by dz, that is the rate of twist. Here that comes in the form of cubic equation, the differential equation. After solving the differential equation, we will get this one, right, from applying the boundary condition A to B, okay, and then rate of twist. second one. Then third is angle of twist. So theta is here, angle of twist. So just see the difference. Rate of twist is d theta by dz. Angle of twist is theta. And angle of twist at the fringe. Okay, so this is angle of twist at built-in. So this formula is at built-in condition, and this is for what? At the free end. So this will be the theta equals to free, that TL by J GJ into 1 minus tan H mu L by mu L at the free end condition. Okay, so now to decrease in the effect of axial constraint toward the free end of the beam is shown by the examination of variation of Saint-Venant and Wagner's theory. So this is sum of these two is only the total torque, right? Torques along the beam. So now just see Tj is what? Gj by d theta by dz, right? From the Saint-Venant. That Tj, Saint-Venant, torsion. Gj, d theta by dz, what we got? That is the here d theta by dz. T gj. Okay, let's just here. First tj equals to gj into d theta by dz. So I'm writing here. Then it will be easier. So tau or t j, that Saint-Venant is equals to what? This term. Gj into d theta by dz. So gj into d theta by dz. This is there. Just now we found d theta by dz here. That's why I'm writing in this slide itself. Then it will be easier. So now I'm putting here. So t, therefore that Saint-Venant is gj into d theta by dz is this one. So into t by gj into 1 minus cos mu L minus z by, cos mu h mu L. Gj cancel. So t of j, right, is equals to t into 1 minus cos h mu L minus z by cos h mu L. Okay, so this will be the value of t g j. So just here, this is t g j. Now from the Wagner's theory, what is Wagner's theory? That tau equals to tau of tau is equals to minus e tau r into dq theta by dz square. Dz cube. Now what is required here? That to put the value of tau z and dq theta by dz cube. So just see here, dq theta by dz also we found here. dq theta by dz is this one. We can take that side. So this will be minus mu square tgj by mu square d theta by dz. So now d theta by dz, again we have to replace what we got. This value, right? So just here. Okay. So after simplifying this one, what we will get? That t equals to cos mu into L minus z by mu into. So only this term will left. Okay. So this is tau r. Just after substituting the tau r value, the tau r in first itself we found. Right. So what was tau r? Let's see here. Yeah. For this way. Right. So just simply or just see here. D theta by dz we have this one. Okay. From here. Just substitute dq theta by dz cube in that equation and then further simplify. So after that theta will be equals to t into cos mu h into L minus z by cos mu L. Okay. Now just apply the, from here what we can say the total torque, or just here that equation is written. Right. Substitute here. Gj into d theta by dz minus e tau r dq by theta by dz. So what is that? The final one will be sum of these two. So total torque will be equals to what? This term. So T into 1 minus cos h mu L minus z by cos h mu L. Right? 1 minus, and then plus, so this is first term, plus this term, plus t cos of mu, cos h of mu L minus z by cos h mu L, right, this term. Now see here, p we can take common, right, after taking t, what we will get, cos mu h, this and this will get cancelled, so finally we will get a total torque, and that is only plus t. Okay, that from the Wagner we will get this one. Okay, so this is reference. Okay, let me just recall quickly once again. Okay, so it's a given, derive the equation for tau r for a given geometry. This is there. The similar question was, we had seen for this one, we just projected to this one. So now what we have to do, we have to find the moment along this axis. So this is one triangle, another triangle, so two triangle and one rectangle is in this figure. So now, and that is given from here to here, that is hd by 2. Now next what we will do, to find this one, like 1 dash, 2 dash, 3 dash, 4, take the moment along the s axis, because with this we are taking. Okay, so after taking the moment we will get this equation, right? So after expanding and simplifying, we got 2a r dash equals to this one. Next, what is there? Now we have to find tau r. So in terms of moment of inertia, that we will find. So from that, what we will get, tau r equals to this one. Okay, so now after simplifying, tau r will be this one. So according to the question, that is over here. So only up to this you have to find. Now, if suppose in that they will ask the rate of twist, angle of twist, or angle at the fringe. So now in the same we will see that one. So that's why I'm continuing here. Earlier also told, right? So total torque equals to what? From Venant and Wagner. So this is the Venant one and Wagner one. So T equals to Gj d theta by dz minus E tau r dq by d theta. So now simplifying, for simplifying this cubic, that differential equation, what should be there? The coefficient of dq theta by dz cube should be 1. So what we have to do, just divide E tau r to all the three terms and put mu square equals to Gj by E tau r. So after doing that one, what we got? This equation, right? Now this is the differential equation of cubic power. So for that we will get d theta by dz equals to this term. Okay, now here for finding d theta by, because once we will know the a and b value, that's all, that rate of twist we will get. So because d theta by dz is the rate of twist, for finding a and b, what we have to do, we have to apply the boundary condition. So after applying the boundary condition, we will find value of a, b, and substitute that. So for boundary condition, what is that? First, at the built-in end, w is 0, right? Wrapping is 0 and w equals to minus 2a d theta by dz. So that time what happened? D theta by dz is equals to 0. So means at z equals to 0, d theta by dz is 0. In second case, at the free end, z will be equals to what? L. And hence d theta by dz, that also at the free end it will be 0. So once first after putting the first, that is at d theta by dz equals to 0 and z equals to 0, we will get e equals to this one. Now just substitute and take the second boundary condition, b, we will get this value, that is b equals to b t by gj into tan mu hl. So after getting value of a and b, substitute to the d theta by dz equation, that will just replace a and b. So this will be the d theta by dz. That is the final answer of rate of twist. This further you can simplify and you can write in terms of this one. So d theta by dz equals to, just see. So in question they may ask you like this up to derive rate of twist. Then you can leave here also. Or instead of that, they will give you this equation and then they will ask you to derive this one. So don't get confused. No, what is this one? This, once you will reach here, then their simplification is this one, just to convert in terms of cos of a minus b. That's all. So here what you have to do, just this tan mu l write into in terms of sine, right? Sine by cos. So tan becomes sine h mu l by cos mu h l. Then take LCM from here to here and then simplify, automatically you will get cos a cos b minus sin A sin B, and that gives you what? Cos of U minus P. Right. So here. So after that, what happened? Let's substitute here. You will get the d theta by dz. Right. So now we have the rate of twist. So torsion, rate of twist, two things over. Third, angle of twist. For that, what you have to do? Just integrate it. Right. So after integration, this will be the angle of twist. Okay. Once you have the angle of twist, you can find. Now, so this angle of twist at the at the built-in is there, where z is equals to 0. Now, what about the free end? So for finding at the free end, right, what we can do, that put z equals to L. So after putting z equals to L, what we will get here? So just see, and angle of twist theta at the free end is what? Z equals to simply L. So theta at free end is TL by Gj into 1 minus of tan H mu L by mu L. So this is the final one. Okay. So now that is the angle of twist, that at free end and at the now from the Wagner and Venant theory. So just see what the decrease in effect of the axial constant. So now what will be the total torque is what? Sum of Venant and Wagner. So what will be the Venant one? So Tj is what? Gj into d theta by dz. So just put the value of d theta by dz, that rate of twist. Okay, Gj will get cancelled, and finally you will get t equals to this one. Similarly, for Wagner one, what? This is the Wagner one formula. Put the value, right? Then you will get the value of tau, t tau, that Wagner torsion is equals to t into cos h mu into L minus z by cos h mu L. Okay, so if you have any doubt, or you can just refer this mention, and that's why I mentioned here also that title number, that 27.1. So if you have doubt, you can just refer that one. Okay, so if you have any doubt, you can just comment on the video. Okay, I will clarify, or you can just ask about your doubts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.